Welcome to WOW TV. My name is Angel, and I'm here from the Wizards of Wright program. The WOW program is a part of the Educational Outreach Office here at Wright-Patterson Air Force Base. Today you're going to learn something about flight and testing weight and balance. Are you ready to get started? Let's go. Today's lesson will use what you've already learned about the forces of flight. The four forces of flight are what keep an airplane in the air. They enable the plane to go up and down and forward and then slow down. Airplanes fly because they are able to generate a force called lift, which normally moves the airplane upward. The wings create most of the lift used by airplanes and is the force that holds an airplane in the air. Thrust is the force that moves an aircraft in the direction of the motion. Aircraft use propellers, jet engines, or even rockets to cause thrust. How does this happen? Well, as air is pulled in, air is pushed out in the opposite direction. Drag is the force that slows down the forward motion of the airplane. You've felt drag before. It's that feeling when you put your hand out of a moving car window and feel it pull back. It's the force that acts opposite to the direction of motion, so it tends to slow an object down. Weight is the force created by gravity and is the downward pull toward the earth. When you jump up and down, it's your weight that brings you back down. The four forces of flight are what makes the plane move in different ways. Each force has an opposite force, and it balances that movement and works against it. Lift works opposite of weight. Thrust works opposite of drag. When the forces are all balanced, the plane is level. The plane goes up if the forces of lift and thrust are more than gravity and drag. If gravity and drag are stronger than lift and thrust, the plane goes downward. Have you ever thrown a frisbee? It flies because of these same four forces. As a frisbee flies through the air, lift holds it up. You gave the frisbee thrust with your arm. Drag from the air makes the frisbee slow down, and its weight brings the frisbee back to earth again. When working with new models or products, engineers test, make changes, test again, and make more changes until they have a successful design. When engineers, like those here at Wright-Patterson Air Force Base, use this design process, they have the opportunity to make mistakes and fix them, so they end up with the best and safest aircraft possible. When they use small models for their work, it doesn't cost as much as it would to constantly test with full-size airplanes. Using models was an early design plan used by the pioneers of aviation. They didn't build a flying machine one day and immediately take off into the air. That would have been dangerous. The early inventors and engineers, people like the Wright brothers, began with learning about flight by using kites and gliders. They started experimenting with wing shapes and sizes. They ran tests to see how much weight their kites and gliders could carry. Do you know what the difference is between a glider and an airplane? A glider is an aircraft that floats in the air, creating its own lift and does not use an engine. Today, as engineers, you will be responsible for designing gliders that can either travel a long distance or stay airborne for a long time. Using models helped the Wright brothers learn more about balancing and positioning the weight of airplanes. If the nose or front of the plane is too heavy, that weight will pull the airplane into a forward dive. The weight needs to be evenly distributed for safety throughout the wings, fuselage, and tail. The Wright Flyer was the first airplane to complete a takeoff and landing using a pilot to control the direction and altitude of the flight. Flight control systems manage flight direction. Elevators make the nose of the airplane pitch up and down, and a rudder is used to move the nose left and right. Airplanes also use ailerons to roll the airplane and stabilizers to straighten it out. Now, let's take everything we've learned and put it into action. Let's make some paper airplanes. Teachers, please give students the packet on paper airplanes and several pieces of blank paper. It's up to you if you want your students to work on their own or with a partner. How much time you want to give them will determine how many they build and test. It's possible that some of your students will know a design for a different paper airplane. Maybe they can share that with the class. As your students build and test their paper airplanes, discuss the lift, thrust, drag, and weight of their plane, and how it affects the height and time of the flight and the landing. Are there modifications they can make to increase the flight length or time? I'll wait while you do this. Okay, let's move on to our next activity. I have here a styrofoam tray. What happened? Did it fly? Could I use that as a frisbee? Instead of flying, it kind of just drops. But the ability that styrofoam has to be lightweight and strong makes it a great material to use in making gliders. Teachers, in a moment, please pass out styrofoam trays, glider templates, and plastic knives. There's also sandpaper to share and materials they can add to their gliders as they're conducting tests. There are also student sheets with complete directions. After cutting out the template, trace it onto the styrofoam and then use the plastic knife to carefully cut the parts out. Another way to cut out the parts is by using a sharp pencil to punch a series of holes around the outside edge of each piece and then pushing the piece out. Use sandpaper to sand the edges smooth. Then assemble the glider by inserting the wings and elevator, also called a stabilizer, into the fuselage slots. Teachers, as they are doing all of this, you can decide where and how you want the testing to take place. Before I turn it over to you, here are some things to remember as you are testing. We'll leave these up on the screen for you. The weight must be balanced before it will fly. Test your glider before adding weight and balance. Add weight to the model using paper clips or binder clips or even clay. Try attaching a paper clip or clay to the nose of the glider. Try attaching a binder clip to the bottom of the fuselage. Does more than one clip make an effect? Move the weight forward or backward on the fuselage to determine the best weight and balance for the glider. The best weight and balance combination can be defined as one that allows the glider to fly the greatest distance. Okay, it's all up to you now. I hope you enjoy your gliders. Thanks for joining me. And teachers, thank you for using this WOW lesson. Please check out more at our website at wpafbstem.com.